Hello, everyone, and welcome back to Vision Unleashed 10 Breakthroughs Shaping the Future of Computer Vision. I'm Ramasaya, and today we are here on episode 4 DETR's Decoding, where we'll see how transformers reimagined object detection as a clean end to end set prediction problem. As always, I am joined here by Dr. Sukant Khurana. Good to have you here, sir.
Thanks, Ramesh. Thanks, Ramesh. So this is really good. DETR really turned detection on its head, right? No more anchors, no more
Exact,
non-max suppression, just pure transformer magic. It's
exactly.
absolutely amazing.
Yes, sir. So, yeah, yes, sir. To start with the traditional approaches, like for years, methods like faster RCNN and YOLO relied on predefined anchor boxes and complex post processing to weed out duplicate detections. Then in 2020, Facebook AI introduced DETR, so detection transformer, framing detection as predicting a set of objects directly. How did that insight came out about, sir?
The core idea was to leverage a transformer's ability to predict outputs. But here the sequence is an unordered set of object boxes and labels. You take a CNN backbone to extract grid of images features, flatten it, add positional encodings, and feed it into transformer encoder. Then a transformer decoder processes a fixed number of learned object queries, each representing a potential object slot. The decoder outputs one prediction per query, box coordinates, and class probabilities.
Exactly, sir. That's for the technical part. And so instead of millions of anchor boxes sliding across the image, you have, say, around 100 object slots now. So each slot either predicts an object or a special no object class. How does a model know which query should correspond to like which ground truth object during training, sir?
That's where a bipartite matching loss comes in. For each training image, you compute the Hungarian matching between your n predictions and m ground truth boxes,
Exactly.
minimizing combined cost of classification error or box regression error. This matching pairs each true object to exactly one prediction, and unmatched predictions learn to predict no object. That way, you avoid post processing heuristics like non max suppression entirely.
Exactly, sir. So yes, so like I love that clarity actually, like the one-to-one matching instead of messy overlap thresholds and all. So DETR's results on COCO matched faster RCNN. What about the convergence speeds? Like I recall DETR took a lot of epochs to train when I personally tried that out.
Yeah, true. Vanilla DETR needed around 500 epochs on COCO to converge compared to 50 to 100 for faster, RCNN. To address that, follow-up work like deformable DETR introduced sparse, multi-scale attention that focuses only on a small neighborhood around reference points. This slashes training time to about 50 to 100 epochs while improving performance on small objects.
Exactly, sir. So I actually tested deformable DETR on drone footages for vehicle detection. So the space attention zeroed in on cars even when they were tiny or like partially occluded, and training wrapped up in a fraction of the time. So, sir, take on
Exactly.
it.
This is Yeah, I mean, this is other variants like conditional DETR replace learned queries with dynamic queries based on feature map, boosting convergence further. And Dino combines contrastive learning with transformer detection, achieving state of the art results with simpler training schedules.
Exactly, sir. So now let's talk about the benefits. So the DTR's end-to-end design removes the need to manually tune, anchor sizes, aspect ratios, or NMS thresholds, etc. So for applications like robotic grasping in cluttered environments, this basically simplicity is that the goal feature that you want. So you just feed an image and get a set of bounding boxes and class codes, no extra pipeline steps. So doesn't that simplicity like help a lot, sir?
Absolutely, that's right. DETR transformer decoder is modular, right? So
Yes,
you
sir.
can add extra heads for segmentation, like adding a mask head over each query and get panoptic results from the same framework. That unified architecture is a big draw for industry.
Exactly. So that's how the modularity works. And now there's also the interpretability angle as well here. So each object query maintains an attention map over the image features. By visualizing those maps, you can like kind of see which regions the model consulted to predict the particular box. So in one of my experiments on traffic scenes, attention maps revealed that specific queries focused on crosswalks markings to detect pedestrians, so that was kind of pretty cool for me.
Yeah, absolutely. That transparency helps debug and trust the model in safety critical domains.
Exactly, sir. So I think it's a lot about DATR for now. So before we wrap up, what should researchers keep in mind when experimenting with DATR, sir? The absolute beginners.
Yeah, so first choose the right variant for your data scale. Vanilla DETR for simplicity, deformable or conditional DETR for faster convergence, and Dino for top tier accuracy. Second, leverage multi scale features. Transformer based detectors excel when provided with feature maps at different resolutions. Third, monitor your matching cost weightings. The balance between classification and box regression in the Hungarian laws can impact both precision and recall.
Rightly said, sir. So that was a great advice. And for those with limited compute, there are even lighter versions of DATR like the efficient DATR that prune attention hits or reduce query counts while preserving accuracy.
Yes, the ecosystem around DETR is thriving. We've seen adapters for video object detection, 3D object detection in point clouds, and even end to end instance segmentation modules building on the same set prediction principle.
Exactly. So that's what DATR helps in downstream tasks. So DATR's decoding really, I think, opened doors actually. So thanks, Dr. Sukant sir, for decoding DATRs for us today. Next time on Vision Unleashed, we'll explore rendering reality, diving into neural radiance fields and how they actually reinvent 3D scene reconstruction. So I hope you don't want to miss it.
I'm
So
absolutely looking forward to it. Yeah.
Yes, sir. Thank you. So, thank you all for listening. If you enjoyed this episode, please subscribe, like, and share. I'm Ramasaya. See you in episode 5. Thank you.
Thank you.